Sorry I'm late. I was just having an MRI scan. I was wearing this gas delivery mask so that I could breathe in pure oxygen during the MRI scan. This is safe for short periods of time. Inhaling pure oxygen during the MRI scan produces fascinating results, as the pure oxygen itself causes two different effects which change the MRI images. I'll show you the results from the scan I just had once they've been uploaded by the scanner. When we breathe in pure oxygen gas, the oxygen gas will enter our lungs, and the physics property of the oxygen gas itself causes the lung tissue to decrease in brightness in the MRI images that we take. After entering the lungs, oxygen will be absorbed and dissolved in the bloodstream. The dissolved oxygen will instead cause the MRI image to increase in brightness. Inhaling pure oxygen therefore results in two opposite enhancement effects in the MRI images, which can tell us important information about lung function, about the distribution of gas in our lungs, and the absorption of oxygen into the bloodstream. My MRI scan is now ready to view. Let's have a look at my lungs. This is an animation of the MRI images from the scan I just had, with a slice taken in this direction. In the animation, you can see respiratory motion occurring as I breathe, cardiac motion occurring as my heart's beating, and there'll also be blood flowing through the lungs. These things all make oxygen-inhaled MRI really challenging, because the motion and the blood flow can alter the brightness of the MRI image, which can mask the oxygen-induced MRI image changes that we're interested in. To tackle this challenge, we have developed an MRI method to allow us to observe the changes in the image that occur just due to the inhalation of pure oxygen, without any of the unwanted noise that can otherwise obscure our lung function measurements. This is one of the images from the animation, but it's from a slice just behind the heart. On top, I'll overlay the information that we can extract using our analysis technique. Here, the colours indicate the changes that occur in the MRI image due to inhaling pure oxygen, with red representing an increase in brightness and blue a decrease in brightness. My lungs clearly appear blue, as the MRI image decreased in brightness in the lungs, which is what we expect due to the effect of the oxygen gas, whereas the MRI signal increased in this large blood vessel, which appears bright red. This large blood vessel is my aorta, and as the aorta carries oxygenated blood, we expect the impact of dissolved oxygen in the blood to increase its signal, which it appears to have done. This image is brilliant because it demonstrates that the new approach we've developed is sensitive to the changes in the MRI image that occur when someone breathes in pure oxygen, and it enables us to observe the different changes that occur in the lung tissue compared to the oxygenated blood vessels in the lung. This is exciting because these two different changes haven't been observed before using oxygen-held MRI, and it means that this brings our technique, or the oxygen-held MRI technique, closer to the clinical use as a non-ionising imaging technique that could be used as an alternative to CT scans and X-rays.